Well, welcome back, everyone. It's great to see you here at Forum 2. My name is Alison Krepp, and I lead the social science program in the Weather Program Office of NOAA's Office of Oceanic and Atmospheric Research, also known as NOAA Research. And a big thanks to Cassandra and folks at the NOAA Library for hosting us today. In Forum 1, we focused on metadata standards, why they matter, and how they support discovery and reuse. Today, we're going to build directly on that foundation and move from standards to practice. Again, we've framed these as forums, not trainings, because our goals are not to teach you, but to increase your familiarity. And by doing this, motivate your engagement in these areas. Our focus today is on how metadata unlocks integration and the insights that go along with that when we bring together SBES, or social, behavioral, and economic science data, with weather and meteorological data. Next slide, please. We'll just recap the audience today. We've got a good mix of NOAA and non-NOAA. Looked like from yesterday's responses, we had folks coming in from across the continent, which was fantastic. If you would like, feel free to say hi to us again in the chat, just so we know who's out there in Vimeo land. That would be fantastic. And then we're going to move to the next slide, as this is also a replay from yesterday, and it pairs well with the following thoughts that I want to share. Yesterday, Kyle emphasized that metadata is a bridge that makes our data discoverable, interoperable, and reusable, the core FAIR principles. With metadata, we can generate new insights, support reproducibility, and make our research far more valuable to others. And that honestly is what's represented on this slide right here. These are pulled from what we heard from you in the registration information. Yesterday, we used synthetic data, and today we're going to make things real in a way that has resonance with your areas of research. In Forum 2, we're going to follow a case study. It's going to be a real example of combining SBES, social, behavioral, and economic science, with weather and meteorological data. We'll walk through a workflow, some tools, including a Jupyter notebook, that really shows integration in action. And just in case you forgot, this is an excellent place for me to say you have a role to play today, and we welcome you to jump in and engage. We know that many of you, this is a new area, so try running the code yourself. Even if Jupyter and Python are new to you, this is what the data forums are meant to provide, a space for you to explore. Don't worry about getting everything perfect. This is about experimenting and asking questions so that we can learn together. And for my piece, the last thoughts that I want to leave you with are our bigger goals for building a sustainable community of practice around SBES data integration. Yesterday, several references were made to the fact that this is the beginning, and that is indeed where we are. Currently, we're working toward launching a cloud-based platform, scaling to larger data sets, adding new data types, and eventually exploring how AI and automation can help fill metadata gaps. And this is the place that trajectory starts. Your participation and feedback today is key in helping us navigate this landscape in ways that are responsive to your needs. So, at the close of today's forum, we'll send via chat and email a short evaluation, because as we've said, this is a new format for us, and we're interested to know how this worked out for you and what considerations for the future you may have. Kyle Metta is on deck in chat today. He was on the main stage yesterday, so you'll be able to engage with Kyle if you have questions as we go along, and also look for helpful prompts as we move through today's case study. With that broad recap, I'm happy to introduce John Mote, taking the main stage today. He will be leading today's forum. John is a sociologist and serves as the Social, Behavioral, and Economic Science Data Engagement Coordinator and subject matter expert across a number of the data initiatives with our program, including the Societal Data Insights Initiative. And with that, I'm really happy to hand it over to John to start today's forum.
Good afternoon, everyone, or good morning, depending on where you're at. I'm really glad that you could make it here today. Just one little bit of housekeeping. If you don't have the GitHub page open yet. I'm going to provide the link here. We will turn to that at some point. So thank you for that intro, Alison. I really appreciate it. As she mentioned, today's session is going to build on yesterday's great session from Kyle, where we explored the world of metadata. Today, we're going to take a little different step. We're going to take the next step, showing how metadata can enable integration and reuse across disciplines, especially in this case between social and weather data. We're going to walk through a Jupyter notebook that demonstrates how to pull social data and weather data using APIs, application programming interfaces. I'll describe that in a little bit. We're going to view some metadata. We're going to merge the data meaningfully, and then we're going to visualize the results. Just to reiterate, and you'll hear this a couple more times, think of this as a sandbox. This is not a lecture on coding. I'm certainly not the right person to give a lecture on coding. I'm more of a kludger as opposed to a coder. But really, it's a guided tour of what might be possible with metadata and open workflows. Why do we care about this? In social science, metadata is second nature. We always ask who collected this data, when, how, what are its limitations. Limitations was an interesting topic yesterday. And that same mindset applies to weather and hazard researchers. The metadata we use helps us understand both what our data says and what it misses. So this isn't just a technical term, it's a bridge. Metadata is what allows different disciplines to talk to each other in meaningful ways about our respective data. Why does good metadata matter? Well, good metadata, that's hard to say together, helps you decide if a data set is trustworthy, if it's relevant, and how it fits into your research. Think of this example. Imagine you're linking a survey on hurricane evacuation intentions with a data set on hurricane landfalls. Good metadata makes this possible. The survey's metadata, collection dates, locations of respondents, response rates, demographics, shows who was asked when and under what conditions. The hurricane dataset's metadata, storm name, landfall location, date, time, whatnot, shows which communities were actually at risk at the same time. If we align these through their metadata, we can connect intentions to actual storm exposures and really ensuring that the people who intended, at least in our data set, the people who intended to evacuate were really the ones truly in the path of the landfall. That's done through good metadata. It's tempting just to merge data sets and get to the fun part, analysis, right? But that comes at a cost. For example, let's say you merge a survey from 2015 on flood preparedness with FEMA floodplain maps updated in 2020. You got a temporal mismatch, let alone we haven't even talked about the geographic. But you do that sort of stuff, you'll get misleading results, you'll waste time, and you'll create faulty policy recommendations. So using metadata to align data sets carefully will prevent mismatches in time and or geography. And using metadata will help better document what you did and provide some transparency about the limitations of your data set. What is data integration? I would like to know myself. Everyone, including us, talks about it, but what is it really and how's it done? The simplest form, which we're going to be doing today, is just merging two data sets. You have two data sets, you've got one common variable between them, you merge the data set. Et voila, right? The choice of the common variable is the trickiest part. It could be zip code, could be date, location, a specific identifier. We don't know. It could be any one of these things. And these variables may look the same, but mean different things in each data set. Metadata is what helps us navigate those questions to be much more careful in the selection of a common variable. There's a lot more complex integration that could involve many-to-many joins, harmonizing vocabularies, reconciling data collected at different time or geospatial scales. So metadata becomes even more important once we get into more complex examples of data integration. But we're just going to do something simple today. Probably something you've already done before, but just never thought of it necessarily as data integration. Why do we pursue it? I think that's why we're all here. It's sort of like triangulation in social research, right? Where you want to have different methods, different data, whatnot. So here we're just combining different types of data. In this case, we want to understand what people experience to what the atmosphere is doing. We've got the social and the meteorological. And that sort of triangulation of data allows us to test whether public perceptions of extreme weather are impacted by actual meteorological conditions. It could highlight potential gaps between warnings issued and warnings understood. And it could show whether personal experience with hazards leads to changes in behavior or risk perception, which is what we're going to be looking at today. So there's lots of good reasons why to pursue data integration. What are the tools we're going to be using today? We're going to use Jupyter Notebooks, which you might have heard of before, and we'll be using it with Python. But you can easily use R, Stata, SAS, whatever your particular program is. A little bit of differences with how you use it with R or Stata, but nonetheless, it can be done. It can be accommodated to whatever you use in your own workflows. But we'll be using Python, which I have found, I sort of adopted it late in life. I just find it very easy, and I've tried all the other languages, R, Stata, SAS. I still have many issues with R, but these are great tools. What I like most about it is that it gives you a single place to combine your codes, your commentary, and your results in one place. It's just like keeping field notes and analysis side by side. If you're like me, back in the old days before Jupyter notebooks, I would have things scattered around my desk, and when someone wanted something, I'd have to sort of cobble it together. I was not the most organized person. So Jupyter was really great at helping me organize my analysis and workflow. Best of all, it's open source and free. It's easy to share, and it supports transparent workflows. I sound like a salesperson for Jupyter, don't I? I don't mean to. It's free, so no one can really sell it. You might want to get started with something like Google Colab, which is very similar to a Jupyter notebook. Slight differences, which we can maybe take a look at that today. And then you might move on to a distribution of Python, like the Anaconda distribution. You want to take a look at the additional resources link on the forum's GitHub page to sort of see some other examples of notebooks, ones that you can also download and easily use. And that's really the nice thing about Jupyter. It's a great community for collaboration. There are tons of notebooks out there that you can download yourself and start playing with. You don't have to be a programmer. I want to emphasize that again. Most code examples are just a few lines, and you can copy, paste, and adapt them to your own data. It's just a great way to get started in perhaps new types of analysis. What does Jupyter look like? I'm stealing a slide from Kyle from yesterday. It's really just made up of 3 different types of cells. You've got your markdown cells for notes, explanations, and citations. You've got your code cells that you could run Python, R, or Stata in it directly. And then you've got your output or results cells. That could be tables, charts, maps, models. And you'll really see this in great detail in just a few minutes. But that's really all that Jupyter is. It's just a shell for running code. And it's just, again, wonderful. Given these 3 combinations together, you can really hang together your analysis, results, and discussion in one place. Going back to the APIs, I just want to provide a quick note. If you haven't used an API, you're probably wondering what the heck is an API. It stands for Application Programming Interfaces. And at its most basic, it's just an interface that allows you to interact with another server and access resources, in this case, data. So I want you to think of it like a waiter taking your order, relaying your order to the kitchen, and bringing your food. You just need to know the right way to order your food, right? And we want data here. Most APIs are HTTP-based, so they're web-based. So the endpoint that you make the call to is just a web address, a URL. You just need to know, again, how to construct that URL, and there's Python libraries that help you automate that process. How it all hangs together today, we'll go through these 4 steps where we use an API to get social data, use an API to get weather data, we'll merge the data, and then we'll visualize and analyze the data. Again, I want you to focus on this workflow, not the code. I'll demonstrate some things in the code, but I don't necessarily think you need to figure out like what's going on in this particular cell block. You don't need to become a Python expert. I certainly don't consider myself a Python expert. I would consider myself somewhat proficient. But seeing how this all works together will perhaps, hopefully, help you imagine some new possibilities for your own data. So we've emphasized this many, many times. This is only an introduction. The point is not to make you coders today, but to show you some tools that you can help bridge social science and hazard meteorological science. If you're unfamiliar with Python, it might seem a little bit overwhelming. As I mentioned, R is still overwhelming to me. Again, focus on the workflow and not the code. As we go through the notebook, think about one data set from your own research. It could be survey results, focus group notes, and start to think about what would happen if you could integrate it with hazard data in this type of workflow. And really, that's the spirit of these forums, is to help us imagine some new research paths, practice integration across the disciplines, and begin to build a community that uses transparent, collaborative methods to generate new insights together. And with that, so now would be the time to jump into the GitHub pages. So if you click on the link, this is where it should land you. And I mentioned additional resources. Please feel free to jump in there after this is over. I've got very good links on notebooks that are available, particularly as they relate to social science. But I want you to come right down here to Forum 2, and that's where we're at today. And before we get started, I want to point out that there are 3 ways to participate in the notebook. The first one is a binder book, which is basically just a temporary environment which you can run code or whatnot. And that'll be the main one. If there are issues with that, hit refresh a couple times. It'll take at least 2 or 3 minutes to load. But if it doesn't load, again, hit refresh 2 or 3 times. If it's not doing the trick, go straight to Google Colab. And I know there will be no issues, but it'll look a little bit different than the notebook you'll be seeing up on the screen because I'll be in Binder. If you don't want to do either of those, click on this one and it's rendered in HTML and you can follow along without having to run anything. All right, so let's go back up to Form 2 and go ahead and click on the Binder button and you'll get a screen that looks like this. And you should be looking at something like this when it loads up. Definitely give us a ready in the chat once your notebook is up and ready to go. All right, let's go ahead and get started. So again, Form 2, this is what a Jupyter notebook looks like. Right now we're looking at a markdown cell where we've written out some text that will either let us know what this notebook is about or begin to guide us through the analysis. And that's really one of the best things I love about it, sort of stating up front what this notebook is about and how we're going to do things. And that's really all the notebooks I do have that beginning point. So what we're going to do in here, we've already mentioned this, we're going to work with some APIs. We're going to organize, explore, and download some data sets using some Python libraries like pandas. We're going to merge survey data with some weather data, apply some geospatial tools, create some visualizations and statistical analysis, and really the important point is documenting our process along the way. So I'm not going to repeat the steps we're going to follow. Let's just jump into it. Before we jump into it, sorry, I didn't mean to stop. Think about your own data again, right? So what types of weather-related data might bring some additional insights for your data? What are some questions that you might be interested in? Let me see some responses in the chat to that question. What kind of data are you working on, and what kind of insights do you think you could gain from integrating with weather data? And really, it could be focus group notes, could be interview notes, could be survey data. Okay. So our research question today, I've always been I come from a different background. Weather research is not really my main thing. But after working at NOAA now for 3 years, I was always interested to try to understand how weather and meteorological phenomena impact people's behavior, risk perception, and whatnot, but in a very real way. I know it does, but how do we tease that out? And so for the purposes of the tutorial today, we're going to ask the question, does exposure to watches, warnings, and advisories, weather alerts, have an impact on survey responses to weather risk perception? And eventually, over the course of this notebook, we will get down to focusing on flood warnings, watches, and advisories. All right, so before we get started, again, sorry to keep interrupting here, we got to get our workplace set up in the Jupyter notebook, right? So Jupyter by itself doesn't do a heck of a lot, but there are lots of Python libraries that allow us to do things like visualizations, analysis, data manipulation, and so we need to sort of begin to import into the memory, the engine of Jupyter, that these are things we're going to be using in the course of this analysis. So again, there's a variety of different libraries. To run a cell, before we get to that, to run a cell, we can go up here to run, and we can run the selected cell, or you can focus on this chevron here, which is what I do. I just go and click that when I want to run a cell. There are some keyboard shortcuts if that's sort of your thing, Shift Enter or Control Enter. All right, so you sort of know the mechanics. Kyle likes Shift Enter. I already have muscle memory with the chevron up there, so that's why when I go into Google, I tend to get things screwed up because the chevron is not located there; it's located in your cell. We all get accustomed to routines and how we do particular things. All right, looking at the Python libraries, we've got a variety for data handling. Pandas is a foundational library. You will see it all the time, everywhere. If you take one course or look at one YouTube video, please make it on Pandas. It is like Excel on steroids, and it is the most foundational library for data manipulation in Jupyter and in Python. I've got something like requests here that helps automate API requests. Got some geospatial libraries. some visualization libraries. This is a real strength of Python, I think, that I'm only showing two. There are several more, but really great, powerful visualization tools which you can customize in many, many different ways. So great tools for visualization, some utilities, and then it's got some pretty decent statistical modeling and inference libraries as well. So we would sort of figure out what our libraries are that we want to use, and then we would import them into the Jupyter Notebook. You'll notice here I have import pandas as PD because sometimes you want to import it as an alias. So you don't have to type out pandas all the time, and you can just write PD when you need to call that library. Sometimes you're importing something, but you want to import only one tool within that library. So you would say, from this library, I want this specific tool. So, as you play around with this a little bit more, you figure out what you need to do and what you don't want to do. So this is our first run cell. If you haven't already, go ahead and click within the cell and click on that chevron. And you know it's running, now it's already gone, by the little asterisk going on here. And when that's gone, the cell has run. We don't get any results here because it's being imported into the Jupyter library itself. So there's no result like, you did a good job. If it doesn't show up, then you get an email or a message saying you did a bad job. It'd be nice if we got the thumbs up on good stuff too, right? Positive reinforcement. So first step, okay, we want to use an API to explore a repository, view metadata, and download data. So for this, we've sort of already, as you would imagine, identified the data sets we're going to use. And this first data set is in the Harvard Dataverse. And the API is very well constructed. I provided the API documentation down here, which you should always refer to when you're creating your requests to the API. We use the Python library requests to automate our requests, and Dataverse will hopefully return what we want, and it'll return in a format called JSON, which Kyle demonstrated yesterday, and you might already be familiar with. We can then use pandas to transform the JSON into what's called a data frame, which is just a table, and it's a format that we're all familiar with, as opposed to JSON. And so that makes the results easier to read and manipulate. One other note before we really get started is that not all APIs are created equally, right? There are differences across repositories and data servers. You'll want to check each API's documentation for how to get started, how to authenticate, how to search and access data, and whatever you want to do in that API. So always check out the documentation beforehand because they are different and there are some great differences between them. One of those things is whether the API is open access or whether you need an API key for restricted access. An API is just a unique code that's generated by the data provider that allows users to access the data for this. For this tutorial, both APIs are open access. All right, I'll start doing more stuff now as opposed to less talking. So we're going to do a simple search to the Harvard Dataverse. It only returns 10 results per search request. That's something to keep in mind. We learned from the API documentation. The way I've set up this, the search query, constructing it is, I set up my query term here, I set up the search URL here, and this is the URL, the endpoint that we're going to make that call to, and then I just have it automatically insert whatever query I have in here, right here. And then this is just sort of common setup of that API request. So we'll go ahead and click on that and run, and voila, we did our first API call. Very exciting. Well, what do we get back? We get some metadata back in JSON, right? We're looking for, since we're going to be using later on Joe Ripberger's severe weather and extreme, I always say extreme weather and society data, but I think it should be severe. I don't know. I think he's changed the name of it. We're looking at all of the data sets in the Harvard Dataverse associated with the last name or just the term Ripberger. And so it pulls up at least 10 results, right, because it's limited to that. And we get the metadata. And we see the metadata that we sort of talked about yesterday. We see citations, we see published at, we see descriptions. It's hard to tell, though, because it's JSON, how many different data sets we're looking at. So what we can do is we can take that JSON and we can transform it into a data frame or just a table. And boom, now we have a better understanding of what it is we're looking at, what kind of results we're getting, at least in terms of sheer number. One of the problems with this is it does truncate some of that metadata. So we do an interplay between JSON and data frames to get a better handle on everything. So it did truncate that description, and that's a key part of the metadata that we want to look at, so we can set up a cell where we examine that description column a little bit better for each data set. So in this, we're taking that data frame from before, we're isolating these two columns that we want to look at, and then we've turned it into an IPython frame, which you don't need to know. I don't know why I said that. But here we're looking at the name of the data sets and the description. Right? And so now we have a better idea of at least these 10 data sets, and really what it is we're looking at in terms of what's included in them. What do they cover? Well, what if we want to search for more than 10 results? So we can make an API call that goes beyond the 10 limit, 10 return limit. Sorry, can't talk. By creating a loop, and that's right here with this while true statement. It'll keep looping through our request until there are no more results. That's essentially what it is. And so let's go ahead and run that. There's other parts to it. And you'll see, most API calls of this nature are very, very fast. Most APIs are in good shape. So here there's only 10. What happened? Well, we've set the results that get returned to a limit of 10 by ourselves, by this dot head, which we can easily change on the fly. Let's say we want to see, are there 20? Can there possibly be 20 data sets associated with Jupyter? There are. Well, wait a minute. Let's see how many are actually, because we could keep going 30 and 40. Let's just see the shape of the data set. And so this is another pandas attribute that quickly tells us how big the results table is. And here we see it's got 39 rows, meaning it's got 39 data sets in there. And when you get a chance, play around with these a little bit on your own, and do an exploration of your own terms. Right? So let's do a quick one just with tornado. Right? Click run. This one might take a few seconds because I know there we go. Let's do a quick check on how many data sets are associated with tornado in the Harvard Dataverse. And we see there are 68. So quite a bit more. And you can put in any sort of quick. That's why I have this set up like this, because it's much easier, much quicker to do an API call where we just have to type in the query term that we're interested in. I got to put that in there because I'm going to use the results of this data frame in just a bit. Okay, we go back down to results. Let's just make sure we got the same one. 39. All right. Well, up here we get a lot of information. Let's say we just want to look at some particular columns, so we subset our results. Or we want to look at particular data sets, so we subset our results. We know we're going to be using the extreme weather and society data, so we only look for those names and pull those names into a new data frame. The names for the extreme weather all look similar. WX with a year, last 2 years behind it. So we just put all those in there. Go ahead and run this cell. And now we're looking at only the data sets that we really care about, that we want to work with. Right? Okay, so now we're down to, we've identified a group of data sets that we want to work with. Let's get the data set and files for at least one data set. So we're making another API call, but this one's a little bit different. We're going to make that, here's the endpoint. And now we're adding the persistent ID for the data set. And that persistent ID, in this case, is the global ID, and it's a DOI. So I could just do a query in the same way where I have query and write the persistent ID. I did another way where I have a list of things, and maybe I want to jump around without having to cut and paste that DOI. And so this way is a way of saying, I want this result at this location in the list from above. It's another way of getting at what you want to do. The nice thing about Python is there's, the concept of equifinality is constant here. There are many ways to skin a cat. Sorry, apologize for that. But there are many ways to do the same thing. And so that's kind of nice to have those many options. So we're going to make a call to the API. and get the file level metadata. We're typically getting two different types of metadata from a repository. We're getting file level metadata, which is metadata specific to that repository. Think of it like the Dewey Decimal System for a library, right? It's going to help you locate whatever you're looking for in that repository. And when we do an API call on that persistent ID, we see that there are 3 different files associated with that DOI. We've got a .tab and 2 PDFs. More than likely, the .tab is the actual data set we're looking at. So here's a case where we'll do this later, where we do the ID. Let's use the same construction that we used for the API call up here, down here, to get the full data set metadata, where we're just looking for the global ID within a list of data sets. All right, so now we get the full data set metadata for the year 2018 of the extreme weather and society data. And you'll see a lot of the same metadata fields that we talked about yesterday with Kyle. So we've got data set ID, create time, publication date, citation date, license, is it licensed? Some other ones, we'll see various authors who are associated with this. We'll get that all important description here, which tells us a lot about the data set and whether it can be used. So this is an online questionnaire. It was fielded in July 2018. It has 3,000 respondents on it, 18 or older, recruited from internet panel. That matches the characteristics of the U.S. population. So we get a lot of identification here of what it is we're working with, and does it fit with what we might be looking at, or what we might want to do with it. Gives us an idea of what the questions are and whatnot. So that looks good. I think we want to download the file. So this is a case where we want to look at the data file. We go back up here. This is the data file of the 3 files up here. Here is the ID for that particular file. And we can now, in step 1B, download in that file. And here I've set the call up similar to what was before, earlier, where what's the file ID? That'll get automatically inserted into the API call here, which again is just a web URL. We use our requests library, and then we're going to have it read directly into pandas as opposed to just raw data. And here we go. We got the data set. It is that easy. As long as you know sort of the website, the web endpoint, and how to construct that query, it is that easy to pull data from the API, to find, locate, examine the metadata, and then eventually pull that data from an API from another server. So we can sort of see that, this is a survey. We've got some demographic categories here. We've got the begin date time. Oh, wait a minute, it's short. We can have ways of expanding the data table, but by default, it gives us a truncated version. So this ellipsis right here tells us that there's a lot more going on in the middle that it's just not showing us. But we don't need to necessarily go into how you might expand the data frame. But yeah, it looks like we got what we wanted. Again, date, time, yep, confirming, all that kind of stuff. Well, let's examine the data set. Anytime you get a data set, I know if you're like me, you do the same thing. What's in this? What am I looking at here? Is it problematic? So we can look at the shape, first of all. 3,000 respondents. Okay, we got what the description said. We can at least run a quick summary statistics. There are other ones too. Again, Pandas has got a very powerful set of ways of examining data. So this gives us just count, mean, standard deviation, min, max, and that kind of stuff. But there are other ones that you can run. Is there missing data? This is particularly important for stuff. And I'm having it tell me, give me a count for each column, how many missing values there are. This is really great to see, because we see, again, we get the truncated and we can expand that, but we're seeing 0 missing values in this data set. If we see numbers in here, then we could run another cell that says, show us where those missing data take place, and what's happening there. Is there a pattern to the missing? Right? All the things you would do when you normally get a new data set. All right, next we're going to take a look at the variable names contained in the data to help us sort of understand what that common variable that we might use to link up with some weather data. Typically, geographical variables are a good start, but I want you to sort of help me Think about this. So after this next cell, I want you to see if there are any geographic variables or any other variables that might be useful for integration with a weather-related data set. And please respond in the chat. So we run this cell here, and it gives us a list of all, sorry, I'll move up here. It gives us a list of all of the variables in the survey data set. And like most survey data, you've got your demographics up here, age, race, gender. You've got some other ones here, state, zip, NWS region. I'm seeing some things that might look good for integration with weather data, lat long. And then we get into the meat of the survey, specific risk questions. There are many. This is a pretty extensive data set that Joe and his team put together. Keep going down, and we see some time ones that might be interesting to utilize. Also, I think we want to take note of the fact that there's census proportion, survey proportion, weight factor, right? So to make this data set nationally representative, there was some weighting of the variables. And so we're not necessarily going to be concerned about that today, but if you want to utilize a data set like this, you would need to take those into account for your analysis. So do I see any good possible variables there for integration with a weather data set? National Weather Service region. Just a word of warning to everybody. If I don't get responses in the chat, I'm going to start doing the Ferris Bueller teacher, okay? I'm kidding, I'm not going to do that. Zip codes, right? So we got some good possible variables here. We've got state, zip, lat long. I am curious about National Weather Service region, so we can sort of find out a little bit more about that with this quick piece of code here, where basically we're saying in this data frame, in this column, what are the unique values in that? And we run that and we find out, oh, there are 4 values, the 4 regions, NWS regions. And you can do that for any of the variables. You just change the name of the column in this particular piece of code. Unfortunately, NWS region only has 4 regions, so not necessarily useful for our purposes. I think that would be overly broad for integration with weather data in our case, because we want them to attach to respondents. But it might be useful for different research questions, or keep that in the background. So for our purposes, we're going to focus on lat long, and we'll use begin date to identify 3 days prior to beginning the survey. Whew. Let's stop and take a breath before we jump on to step 2, which is jumping into the weather. So at this point, we've got our survey data set. We have a decent understanding of what's in there. We have an idea of the variables we want to use to integrate with the weather data set. Are we good to go? How's everyone doing out there? Ready to go? Keep going? ¿Listos? Vamos a empezar. Okay, thanks, Katie. All right, step 2. We've done step 1. We've done the social data. Now it's time to move to the weather data. And here we're going to use an API to download some weather data. We kind of already have an idea of where we're going. I did not necessarily want to pull that metadata. But we're going to use Iowa data from the Iowa Mesonet archive. And we're going to use their API to pull that data. Because we want to be able to, in this case, utilize National Weather Service alert data, right? Those polygons, they keep a nice archive of it. I don't know, can't remember how far back it goes, but we want to sort of begin to think about, okay, what kind of weather alerts did survey respondents experience right before they took the survey, and did that have an impact on their risk perceptions? At least that set of questions. All right, so sometimes calling an API can be a little slow, and it really depends on your internet access as well. So we're not going to do the API call. I pre-downloaded the data, and we'll just do a simple data merge, but I did want to show you what the API call looks like. It's a little bit more involved than the previous API calls. So the code below that I'm going to show you is doing a lot of work in one cell block, because it's going through the survey data one person at a time and asking the Iowa Mesonet API, given this person's location and survey date, what watches, warnings, or advisories were active in the few days leading up to that date. So it's kind of like if you were a survey responder and you had your spreadsheet in front of you and you went by respondent to respondent and call the weather hotline and say, okay, I've got someone who lives in this city. What were the weather watches and what were the weather alerts on this particular day? And then writing it down and then going to them. And so this is being able to call that automatically and do it quite quickly. So here's what we're going to be doing in this next cell step by step. First, we're going to make sure the date is in the right format. Not necessarily always needed, but I always err on the side of caution and being careful about things, and I don't want that to be the glitch that stops my API call, because if something goes wrong in the API call, it'll be unsuccessful. So this is something that I've learned over time. Date time formats can sort of make things glitch a little bit, so I always add that at the beginning. I prepare a there we go. I prepare a place to store the results. So I create a new column in my data set that we just downloaded up above, and it's going to be called WWA names. And in this column, which is going to act like a bucket, it's going to hold a list of weather events, weather alerts that I find for each respondent. And it's going to throw it into that column. Then I'm going to go through each respondent one by one, and for each person, I'm going to look up their latitude, longitude, and their survey date. I'm going to define a 3-day window before their survey date, so we catch those 3 days prior to taking the survey. And then we're going to build a request to the API using their location and dates. And then we're going to ask the API for weather alerts around those parameters for each respondent. So this is not one API call. This is 3,000 API calls. So it might take a little bit of time. That's not why we're not doing it. In my case, it took about 20 to 30 minutes to do all of this. And it's really fun. I set up a TQDM is the utility here, and it's a little progress counter. I put them in all of long calls like this. And it's just, I don't know about you, but I just love seeing that little counter get closer and closer to 100% without stopping. Remember, API documentation. So here's the link to the Iowa Mesonet API guide. Always check the API documentation before you do it. And here's what that whole API call looks like. Right? Date time format. I'm creating a new column. I'm looking at the lat, long, and the begin date for that when that person started the survey, and I'm creating a 3-day time delta before that. It automatically builds the API, and then we have a loop down here that loops through all 3,000 respondents. And you don't necessarily need to put this except in here, but it's always nice to know when something goes wrong and perhaps stops the API call and helps you debug it. That's just, again, that's something that you learn over time, or that you see someone else has done in a notebook, and you're like, hey, I'd like to do that too. That looks good, which is probably what happened here. All right, what we're going to do though is we've already pre-downloaded the data. We've got 2 data sets now. We've got the survey data that we created, that we downloaded up above. We've got the weather alerts data that is the persistent identifier from the survey and whatever weather alerts we downloaded from the API. And we're going to join these 2 data sets. We're going to do a left merge on both tables using that persistent identifier from the survey data. It only has, the weather alerts data only has the persistent identifier because I created that data set from what I downloaded in that call. So I should point out that I have set this up so that you can run this on your own when you get the chance. All you have to do is remove the triple tick and the Python and click run, and it'll run. Please don't do it now, because then you're going to be tied up for 20 to 30 minutes. But down here, we're going to do that merge right now. We're going to download it from stuff we've stored on the GitHub page. We go ahead and run this. It's not going to show us. We didn't set up in this code cell block some sort of pandas data frame. We're going to do a quick check here that I actually learned I had to do, which is basically convert that column to AST, or we use AST to convert it, because sometimes Python lists cannot be easily read in, so this makes sure that it can be read in and we can actually see it. All right, so let's take a quick look at what we've got now. The name of the data set remains the same because we did a left merge, and so we're merging the weather data into the data set we had created above. All right, so let's take a look at it. Hey, look at that. We've got our survey data, which we recognize from up above. Where is that column? And boom, we've got the weather data that we want on here. Okay. let's just do a quick subset to make sure we've got what we wanted, or we can see what it is. We got the precision identifier, we got lat long, we got begin date, and we got that. So we're looking at we're in decent shape. Remember, there were 3,000 respondents. Let's do a quick check. Do we have those 3,000? So we do that shape again. Yes, we got 3,000. This is a good thing to do to make sure that your merge or your integration actually work. Because if you don't end up with the same amount of items that you start off with, something went wrong along the way. And then we can do some quick checks to see, like, well, how many respondents experienced weather alerts. And this is a fairly elaborate piece of code. Basically, it's just counting up in each of those buckets or each of those columns for respondent, what was the sum of respondents who had weather alerts. And here we see that out of 3,000, 1,700 had results. Well, how many people had more than 2? It is taking the same thing, just adding or changing the number to 2, and then adding a subset. Really, again, one of the cool things about Python is you can sort of accumulate and aggregate code as you go along. So let's see how many people had 2, and it'll quickly run that. I'm not doing a sum here, so I'm not getting a number, but we can see that in the results here, without even running the shape, we get a sense of, okay, it's got 1,098 rows. That means over 1,000, about 1,100 people had 2 or more. And again, this is easy to change. Let's say we want to see how many 5. Go ahead and run that, and 677. So we're looking at large chunks of people experiencing large numbers of weather alerts 3 days prior to taking the survey. All right, you've got your data set. You're ready to go. You can export it now and get it into your regular workflow, whether it be R, SAS, SPSS, data, Excel, really anything. Jupyter is fantastic for grabbing data, manipulating it, getting into the shape you want, and then you can easily put it back into your own workflow. And I've created, showing 2 snippets where you can download as a CSV. Again, this is one of the beauties of Python. You simply say to CSV, and you give it a file name for it. If it's a larger data set, more and more people are using Parquet. And again, it's a very simple command to Parquet. So at this point, we've got our data set. We've downloaded it. Maybe we want to stay in Jupyter and just do some quick visualizations and analysis. At this point, let's stop and take a break, 10-minute break, and we'll come back and we'll do some visualizations and we'll do some analyses and have more fun, as far as I'm concerned. This is always fun for me. So I will see you back here in 10 minutes. Welcome back, everybody. Hopefully you had a nice breather, got some water, coffee, whatever. A chance to relax a little bit after what we did a lot of work over the first 3 steps. Just to recall, we explored an API to get metadata on a data set. We then made a call to the API to download that data set. And then we made a call to another API and downloaded weather data. And then we combined those data sets. That sort of workflow works for anything. So there were some examples in the chat. One was park visitation and weather conditions, right? So an API call to, I'm not sure where it would go. Sometimes that's the challenge with what we're doing here, is trying to find those data, but making that API call or already having it existing on our computer, pulling that data, looking at it a little bit, is there metadata associated with it, pulling some weather conditions from perhaps NCEI, precipitation rates, actual precipitation, and beginning to explore the relationship between weather and park visitation. There was also some disaster recovery. Someone said disaster recovery, a survey on it. You could pull weather conditions. You could pull something from the storm events data set and see to what extent there is some correlation between natural weather hazards and disaster recovery. So this is a workflow that can be used in a number of different ways to combine not just 2, but we could begin to think about 3 or more types of data sets. But that workflow is consistent across whatever data sets you're looking at. You're making API calls, you're exploring a little bit, and then you're merging on that common variable. All right, so you've got the data set, you've downloaded it for use. Maybe let's stay in Jupyter and see what kind of insights we can glean before we actually dig into it, perhaps in our own workflow in a much more substantial way. We can get some quick hits here. You can do the substantial analysis in Jupyter as well, but I want to recognize that this might not be everyone's cup of tea in terms of analysis. You get used to R, you get used to SAS, maybe stay in there. But you might begin to explore a little bit more and more of Jupyter and see what capabilities are, and get a sense of that combined data set and see what is it worth continuing down this path. What kind of insights might we see when we work on that data set in our own workflow. So we're just going to do some quick visualizations. Right, I'll go over 3 of them. I'll demonstrate one of them, or I'll demonstrate 2 of them. So the first one is, for my interest, I want to know where these people are in the country, right? Who are these people, and where are they in the country? And this is where some geospatial libraries come in. We use that lat long, right? We convert it to numeric so the library can read it. And then we use geometry, or we lead to geometry, but we use point, because we take that lat long and then we draw a point on a map. That's what this is happening here. And then we use geodata frame as the map that those points are going to go in. We count the WWAs per person. Again, that's a little involved there. And then we just plot it. And then we get something that looks like this. Oh, you know what? I should have remembered this. One of the drawbacks to Binder is that the engine dies after 10 minutes. So what I'm going to have you all do is go ahead and refresh this page, which should give us back our Python kernel right up here. And we see that, and it says idle, but at least it's connected. And then we can scroll down to where we left off. Actually, let's do this. Let's scroll down to that Iowa Mesonet API call. Sorry, it's probably disorienting to see all of this. All right, we're going to go to here, click inside of it, go up to run, and then click on run all above selected cell. So we're going to run all of the cells above this, so we get caught up to at least this point. And let's see what the progress is. We've got no little asterisk, so it has run all the way up there. So now we can go back to, after this, we'll just run these real quickly. Run, 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 run. All right. And now we are caught up to where we want to be. That was a nice way of showing also just how quickly Jupyter can run, right? You don't have to necessarily, you might set up different checkpoints throughout, but if you want to get to a point in the middle of a notebook, run all, and it'll just go. If there's not anything really elaborate going on there, it'll get quickly to the point where you want to be. All right, so let's go back down to visualizations. Let me just make sure that the data set is actually in place. All right, and so then we have exported. All right, so now we're going back to the visualizations, and my big unveiling moment is already gone, but boom, now we get the visualization we wanted, where we see where survey respondents reside, and we have the number of weather alerts that they have experienced. And to me, this is a rather illuminating visualization, because it shows me not only, earlier we saw people experience a lot of weather alerts, beyond 5 per person. But we see that they're in clusters, which of course makes sense because we're talking about weather, and weather happens this way. And so it's really interesting to see the particular clusters, and makes me wonder what's going on there. Like, what was the event? And so, you could then begin to think about what additional data you could add in here. And for me, it's the storm events database. I'd want to know, what was that event? What were some of the aspects of that event? What were the socioeconomic impacts of that event, right? And then you could think about, okay, you've got the weather alerts, and then you've got the actual meteorological conditions they experience, and you can begin to tease out which one was stronger in terms of, if it does have an impact on their survey responses, which one was stronger. So this is, to me, is a very interesting visualization. It's a little bit more elaborate to set up, as opposed to the following one, where we just want to get a count of how many flood alerts were there, how many severe storm alerts were there, and this is just a bar chart that you would normally see. But again, it sort of tells you what were the events that most of these people were experiencing. Mostly floods, flood advisory, flash flood watch, flash flood warning. This is in July, so I'm actually a little surprised to see only a couple of heat warnings, because there's 3, heat advisory. Because if you go into the storm events database, storm events are one of the most predominant events. So can quickly and easily do some visualizations. I've left one here for you to run on your own. If you remove the triple tick and the Python, you can go ahead and run it. I'll let you do that on your own time. I certainly keep this notebook around so you can play around with it. Okay, so that gives us sort of descriptive statistics about the watches and warnings. Now we want to sort of understand those weather alerts by survey responses. And so now we get a little bit more involved here. And we want to examine how the presence of recent weather, think about our question here. We want to examine how the presence of recent weather alerts 3 days prior to taking the survey correlates with survey respondents' risk of that hazard. So we're going to focus on the flood-related weather alerts. I always want to say WAWAs, but weather alerts. How can we do that? We're going to create 2 groups of respondents, those who experienced a flood-related weather alert prior to the survey and those who didn't. So 2 groups. Then we're going to extract the risk perception scores for a hazard. For risk, it's 1 no risk, 5 extreme risk, and then we're going to create some comparative evaluations or visualizations. So in this case, we could do that in 5 or 6 cells, but we can also create a Python function that does all of that in 1 cell block. And so that's what we're doing here. In this case, this is an example of where we're creating the keywords. We're taking the flood risk numeric column, and then we're creating a categorical column to go along with it. This definition will sort of then do the other things that we talked about. I just get into it a little too much because functions can be quite difficult to discuss or difficult to explain. But after you run that definition, let's take a look at what we've got. We've got that column we created of weather alerts and their names. This is that splitting into 2 columns, right? It's you can think of it as a dummy if you want. That would not necessarily be the case. What it actually does is create a Boolean where it's true if you were exposed to weather alerts and it's false if you weren't. So we've got a Boolean column there. We've got their risk flood number, and then we've got the categorical label that we created. All right, well, let's visualize this. We can run this really quickly. And boom, we've got our 2 groups and the responses of risk perception for each category. So the blue is the no, didn't get any weather alerts. The orangish, is yeah, I got a weather alert. And then what they reported in terms of their risk perception to floods. And these are nice to look at, and we can certainly do a lot to change the color and everything. But again, this visualization, it's descriptive. It really doesn't tell us much, right? We can't see any discernible patterns necessarily, except that more people experience moderate risk or reported moderate risk, but we don't see any differences between the 2 groups necessarily. I've created another visualization, which you can run at your own time, removing the triple tick in the Python. It's just a proportion and creates a stacked bar chart. Again, just trying to show you the different kinds of visualizations that are possible. Many, many ones. I also find violin plots interesting. I have a background, somewhat training in demography, so I always have a soft spot for population pyramids. And so violin plots are very similar to that. I think they can sort of suggest visually better than a bar chart can oftentimes. And so, And so here we see the lower reports of risk perceptions, no to some, and then the extreme responses of risk from high to extreme. And here we see at those low levels, people who didn't have any weather alerts, it tends to be a little bit bulgier. I know that's not a technical term. A little bit bulgier than those who did have experienced weather alerts. If you look at the high risk responses, it's a little bit more narrower with those who didn't as opposed to those who did. So it kind of suggests that if you experienced or you were exposed to weather alerts immediately prior to your survey response, you are more likely, perhaps, to say that you're at higher risk. You understand the risk. You've been faced with the risk, right? It has shifted your perception of your risk to that particular event or weather phenomena. It doesn't necessarily pinpoint it, but it seems a little something to explore, right? This isn't necessarily a webinar on statistical analysis or analysis in general, but I always find this is the fun stuff, right? This is why we want to combine data, because we begin to sort of locate and identify some insights like that. So the visualizations are great; they're very pretty. You can customize them in a number of different ways, but we got to pin this down. We got to take a look at the statistics and really analyze what's going on here. So again, just giving you a smattering of what's possible in Jupyter. I put together a chi-square, which we're all familiar with, and I've also created a logistic regression with the binary dependent variable, split the categories into from 1 to 3, sort of low risk, and then the 4 to 5 to high risk. And that is the dependent variable we're going to look at. But then I also set up an ordinal logistic regression because we want to keep that movement from either 0 to 5 or 1 to 5, and see, if that sort of impact or the probability for movement to 1 is different or statistically significant. So running the chi-square, we got to first create that contingency table. We don't have to do a lot of work. We just say, here's the table, here's the columns we're looking at, and pandas gives us a crosstab with that attribute there. So we can run that, and boom, we've got a nice looking crosstab table that we really didn't have to work too hard for. Well, let's test it. We're using a particular library on chi-square analysis. We're asking it to do a chi-square on the table we just created, contingency table, and we go ahead and run it. And we get a result that we had hoped for, which is something that is highly significant, p 0.0008. So it suggests that our intuition from that violin plot and our intuition that led us to this question in the first place, there might be something to it. People who were exposed to flood-related weather alerts did seem to, or it suggested that they responded differently in terms of risk level than those who were not exposed. Well, I wouldn't want to hang my hat on a chi-square, so we continued down the road of different analyses. You can do a logistic. I've got it set up here. We can do an ordinal because we want to see that movement in the dependent variable between levels of risk perception. And I don't really want to get into a big discussion of this. I'm running this because I need the results later when I do something else. All right, so we get the results here. Really, the one to take away is that flood weather alert exposure, right? We got a nice, fairly decent size coefficient, but highly significant. Again, suggesting that exposure to those weather alerts does push people into thinking of themselves at higher risk of that particular event. It's pretty significant. Well, p-values are great, and we now know that it moved the needle. But for me, it's always nice to know, well, how much did I move the needle by, right? Something can be statistically significant, but not really have a significant impact in terms of some sort of policy change, right? You're only nudging the needle a little bit. So I want to know how much is that needle going to be moved. So this, again, this is one example of the possibilities within Jupyter and a particular Python library. We can look at predicted probabilities of survey responses. So we're taking these particular coefficients and we're going to use them to calculate probabilities of responses in two groups. We're going to take the entire sample and we're going to say no one experienced a flood weather alert. And then we're going to take the same group and create another hypothetical saying everyone experienced a flood weather related alert. And then we're going to calculate those probabilities of what their survey responses might look like, and then see if there are any differences between the two. And there's a surprising small amount of code we had to do to write this. But here we see those probabilities, and we see at the lower levels of risk, the people who had the hypothetical group that had no exposure obviously show more responses, a greater number or higher probability of responding with low risk. But as we move up to those higher levels of risk, it's predicted that people with exposure, based on that ordinal logistic regression, that they will respond a little bit more. And we can see the differences between the expected probabilities. So we get a little bit better sense of the substantive significance. How much was the needle moved by those weather alerts? I'm just walking you through one potential workflow of an analysis, and I'm not a good statistics person. I'm sure there are many out there who would be like, why aren't you doing this? That's up to you now. That's your job. I've sort of shown you a tool on how you might go through that. But you may not necessarily want to do that in Jupyter. But now you've got an idea, and you can go, okay, now I know what I'm going to be looking for, and I go back into my regular workflow and my usual language, R, SAS, whatever. But Jupyter got us to where we wanted to go. We got the data set we wanted, combined data set, integrated. We did some preliminary analysis. We have a decent idea of where we're going to go, and then we can jump back into our regular workflow. But you've also got now something that you can share with others, right, and collaborate with others and say, here, I did this. Got any ideas? Run it yourself. How does the code look? And then begin that collaboration process. That's one of the beauties of Jupyter Notebooks. I did a possible interpretation and visualization. We can take a look at that real quick. And it's basically that same bar chart from above, except now we're using just different values. All right, well, we're now at the end. We can wrap up. Remember what we did here. We did a lot here. I'm sweating. We worked with some APIs. Again, that's something that you would normally do. You might already have the data. You can import that into Jupyter. You can then do a call to API. There's many different ways to do it, but Jupyter is a great way to access and store and manipulate data. We use pandas to explore and organize the data. We merged the data. We applied geospatial tools to handle location-based data. We did some visualizations. We did some statistical analysis, and we documented the process in one clear notebook with code, with some commentary, some code, and the results, all in one place. We can easily share that now. So hopefully it is clear that Jupyter is not just a place to do analysis. It's really a research lab. You can play around with this. You can do lots of different things. You can clean it up later, right? So it looks like we're so smooth. Like this one. This one was a mess 2 months ago, and over time just cleaned it up and just made sure everything looked good. But it's a communication tool. I can show you, I can demonstrate to you the process of data integration in one notebook. So moving forward, try this out. Download it or keep it. We'll keep it up in the binder in the Google Colab. It's easy for you to jump in and do that. But begin to do that. Try to adapt this workflow to other survey topics. Your area might be heat, could be drought, could be tornado. It's easy to adapt for those other types of things and explore this question and get sort of familiar with Python and pandas. You can also use this to explore other APIs to enrich your analysis with different kinds of data. We talked about park visitation data, disaster survey data. If you already have that data set in there, you can easily pull it into this notebook and do the API call perhaps to Iowa Mesonet and combine your data with that. These things are easy to shape and change according to whatever your needs are. Of course, you'll learn Python along the way in pandas. And be sure to share. I've provided the link in the additional resources to a number of different Jupyter notebooks. I've probably got, over the course of the last 6 years, 200 notebooks that I've created, but I've created them by borrowing and adopting multiple Jupyter notebooks, right? That's the beauty of these things. People put them up there to share, either on GitHub or other places, and you can see how they did it. Oh, I like that code, and you can copy and paste it and adopt it for yourself. And that's, again, so you don't need to exactly need to know Python. I certainly don't, but I've certainly borrowed enough over the years from other people to learn how to do certain things. And again, it'll take a while, but you start by jumping in now and learning how to perhaps build this into your current workflow. So the key takeaway, with a few tools, APIs, pandas, geospatial libraries, and Jupyter notebooks, you can connect diverse data sets, analyze them in context, and tell meaningful data stories about risk and society in one place. And that sounds like a salesman, in one place. But really, it's just a wonderful tool that I have found extremely useful over the years. And I will stop talking, and I really thank you for following along. If you have any questions, if you have any comments, please put them in the chat. I know I talk too fast, and I apologize for that. But really looking forward to continuing this dialogue with this community around these tools. I think they could be very beneficial to the exploration of additional data sets and connecting those data sets together. Thanks, everybody.
Thank you so much for walking through this data integration and showing us what it looks like in real time. I feel like it is one of those words, much like collaboration. People talk about it a lot, but what it actually looks like and what it actually means sits behind kind of the green curtain of the Wizard of Oz sometimes. So thank you so much for pulling that curtain back for us. I will say I did put the additional resources that John was just talking about. There's a link in the chat to those if you want to check those out. And as we said at the beginning, we are really glad that you came, and this is a different area for us. We're very excited about engaging with the community in this way. So Katie is going to put a link in the chat to an evaluation form, and we'll also send it out. So for those of you that maybe are listening to this recording, we'd also love for you to fill that form out if it's still live. At this time, we can happily take questions that folks might have, having been through the full content of our forum today. So if you have questions, please feel free to put them in the chat, and we'll be happy to address them.
One of the questions in the survey will be, do you want to see more stuff like this? And we can ask you that right now. Is this the kind of content? Would you like to see more like this? Or is there something more specific that you'd like to see? That's the kind of stuff we would like to know. We would like to be able to provide more resources, more tools, more content to this community and begin that process of collaboration and sharing with everybody. So let us know either here or on the forum. It would not be hard at all. I don't think I can pull it up quickly, but in that call, the API call, there's a time delta, and I'd set it up with 3. All you have to do is change the number 3 to the number 5. That's the beauty of some of those tools. By saying time delta, it's saying create a 3-day begin date time and end date time. No. So there are a number of different ways to create a notebook. You could do it in Google Colab. You do have to have a Google account to do that. But let's say you create a Google Colab notebook, and then you want to leave it. Well, it'll stay saved in your Google Colab area. You might want to download and install Anaconda, which is a distribution that includes Python, and then it becomes something that you save locally on your computer. You could then, but you could also post it to Colab. Once you create that Jupyter notebook, it is interoperable with Google Colab. I would say that after working with Jupyter notebooks for many years, this is the first time I've ever used Binder. So Binder is not the go-to. That's if you want to do something like, for me, if you want to teach about it, if you want to show, demonstrate, Binder sort of creates a virtual environment for your notebook for people who want to play around with it or whatnot. But you don't necessarily need to do that to share it. GitHub is a great place to share as well. I don't use it as much as I used to when I was in my last job, where we had to share everything on GitHub because we were working, there was small teams of us working on notebooks. So we would have to put it in GitHub, we'd have version control, we'd have who made the last change or the last mistake, things like that. So GitHub is a great place to share your notebook. But if you have Python located on your computer, it just becomes a regular local thing that you can save. And then you can, if you want to share it with someone, you can email it to them. Attach it to an email. So lots of different ways to utilize and share these notebooks. Kyle and I are constantly shooting back notebooks to each other. We should start doing that on GitHub.
Glad that was helpful, Amy.
Any other questions, comments, observations?
So that's a good question, Taylor. Do you share new copies each time, or is it like Google Docs where you can edit together? John, you thinking on that one?
I'm thinking on that one. Kyle, why don't you chime in on this too? I have never experienced collaboratively working on one notebook. Usually it's iterations. I work on it, you work on it. You can work on it together if you're, like in this venue, one person has it open and the two of you are going over it. But I've never experienced a case where the two people are in the Jupyter notebook at the same time. Is that possible in Jupyter Hub, Kyle?
So there's a couple options for that. So if you're doing Google Colab, right, that has multiplayer, so like live editing, just like a Google Doc. And then there are tools like Azure and some extensions to regular Jupyter Hub that would allow you to have multiplayer. It can quickly become a headache, but it can also be really helpful when someone just comes in and helps you with something. But you can imagine if John's running code cell 2 and I'm making edits in 3 and don't realize that he made those edits, that you can get into a replication problem. But the Colab one is very cool for at least getting help or edits together.
I would say for your question, Taylor, let's say you downloaded the notebook I just did, and you made some changes to it. You've created a new notebook, right? So you might want to change the text, list that you're the author, any changes that you might have made, and it now becomes a new notebook that you created. Yes, you downloaded it and you used Lamico. Nonetheless, it's yours. You've adopted it. You created it to do something new for you. But that's typically the way you do it, is you share copies like that. A new copy can also be called a fork in GitHub language, if you're doing the GitHub stuff. Again, I used to do it all the time. I got out of practice. It is a good way to keep track of version control, right? Who made what changes if you're using the same notebook, right? But if you've changed the notebook appreciably for your own purposes, it is now a new notebook, I would argue.
Sure thing, Taylor.
Any other questions? Observations? Kyle bringing up fork just reminded me I was going to make a comment. The language of this area that is used always cracks me up. Fork. There's a Panda attribute called explode, which I love. We've got the website Hugging Face. We've got a Python library called Beautiful Soup. So I love some of the names also involved here. That's right. So it's a very fun community.
Right, guys. Well, I feel like we've given folks in the chat a bit of time to be able to get their questions typed in if they have them for us real time here. Certainly, I think I can happily speak for John, Kyle, Katie, and myself. You're always welcome to reach out to us with questions if you have them. We will also be reaching out to you with if you didn't get the link now, we will also send the link out, because we know we have some people live, but we also know we have some people who will chime in and tune into this at a later point. So I just want to say thank you for taking some of your morning, afternoon, or evening with us, depending on your time zone, to help explore this space with us. And we look forward to hopefully welcoming you again to a future data forum. Have a good afternoon, and thank you very much.